All right, guys, back here for number 3. Did not do number 2 because it's not a topic that's covered on the AP exam, so we're going to skip those here going forward. Number 3 is a really tricky problem. So there's some parts that everyone should be able to do, and there's some other parts that not very many people are going to be able to do. So the average rate of change on negative 3 to 4 is average slope. We should be able to do that. So I've got a negative 3 something and a 4 something. So if I plug a negative 3 in, that goes here. Squared's 9, 9 minus 9, so we get 0. If I plug a 4 in, that has to go here, so I get negative 4 plus 3 cosine. If I plug a 4 into this function right here, that'll just give me 2 pi. Cosine of 2 pi is 1, 3 times that's 3, so I get negative 4 plus 3 is negative 1. So I get negative 1 minus 0 over 4 minus negative 3, so I get negative 1/7. Part B. This is write an equation with a line tangent. Anytime I see line tangent, I think point and slope. So if I plug a 3 in, that goes into this guy here. So I've got negative 3 plus 3 cosine of 3 pi over 2. 3 pi over 2 is down at the bottom, which means that's equal to 0, which means we get a negative 3 there. The slope, I got to take the derivative at 3, so I'm going to take the derivative of this guy right here, so I get negative 1 minus 3 sine, I think of pi x over 2 as pi over 2x times pi over 2. So I'll put that right there. I plug a 3 into there, I get negative 1 minus 3 pi over 2 times sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. So if I get negative 1 there, that means this just becomes a plus. So I get negative 1 plus 3 pi over 2. So that means my tangent line equation is y plus 3 equals the slope of negative 1 plus 3 pi over 2. That's the slope times x minus 3. You could subtract the 3 over here, but you don't have to. That'll work. Okay. This part is super freaking tricky. So this says find the average value. So if you want some points, you would need to know that the average value is the interval, so divided by the interval. So 1/7 times the integral from negative 3 to 4 of f of x dx, or the whole thing divided by 7. Well, this is split into pieces, so I need 1/7 the integral from negative 3 to 0 of this function. Plus the integral, so 1/7 times all of this, of 0 to 4 of negative x plus 3 cosine of pi over 2x. Okay, so this part we cannot do by hand. It's actually impossible, so we have to know what this graph is. So a circle is x squared plus y squared equals r squared. So if you go ahead and solve for this, you would end up getting y equals the square root of r squared minus x squared. Well, if the radius was 3, that means you would end up getting 9 minus x squared. So this is the equation of the top half of a circle centered at the origin with radius 3. The entire area of that circle would be 9 pi. We are just taking this area because we're just going from negative 3 to 4. So we just get 9 pi divided by 4 for that part. Okay, for this part we have to do this, so we're going to do this problem. So I'll get negative 1/2 x squared plus, so obviously to get this cosine of pi over 2x, I need a sine of pi over 2x. If I take the derivative of this, I'm going to have a pi over 2 chain rule. I need there to be a 3, not a pi over 2, so I'll multiply by 6 over pi. I'm evaluating that from 0 to 4. Plugging a 0 into here would make everything go away. That would be 0. That would also be 0. So I'm just going to plug the 4 in. So if I plug the 4 in, I get 16. So I get negative 8. If I plug the 4 in here, sine of 2 pi is also 0. So I end up just getting a negative 8 out of there. So I end up getting 1/7 9 pi over 4 minus 8. And you could distribute that if you wanted to, or you can just leave it as it is right there. Here it says, must there be a value of x at which f of x attains an absolute maximum? So as long as a function is continuous on an interval, it'll have an absolute max and absolute min. That's extreme value theorem. So we have this function as in pieces. So the pieces are square root of 9 minus x squared from negative 3 to 0, and negative x plus 3 cosine of pi over 2x from 0 to 4. So basically, this is a continuous function, and this is a continuous function. We just need to know if they meet. So I would just plug a value, a 0 into here and a 0 into here, and see if you get the same thing. Technically, mathematically, you have to make sure the limit as we approach from the left is equal to the limit as we approach from the right, and that is equal to the function value. So the limit as we approach from the left, we would just plug a 0 into there. If I plug a 0 into there, I get out a 3. Limit from the right, I plug a 0 into here, so that'd be obviously 0. Cosine of 0 is 1, so I would get 3. And then plugging in the actual value, to plug in the actual value, that would be a 0 right here, which is equal to 3. So since the left-hand limit is equal to the right-hand limit is equal to the value, that means that the function is continuous, and if a function is continuous, then it must attain an absolute max and absolute min. The reasoning for that is extreme value theorem, but you would not have to quote that. You don't have to memorize those. You do get your notes on this test, though, if you need them.